Hello everyone, this is the introductory video on communication systems. We will see some basic terminologies and the basic block diagram of communication system in this video. In a very basic sense, the communication is the exchange of information between two points. And in electronic point of view, using the electronic gadgets and the devices, the information can be exchanged between the 2 points which are far away from each other. So, this exchange of information would be wired or wireless. The communication could be point-to-point communication or point to multi-point, or even it could be in the network also. Many times this communication could be even the broadcast also, where from one station the information is broadcasted, and one such example is the FM transmission, where a reduced station broadcasts the information at a particular frequency, and anyone can tune the receiver to the particular frequency or channel to receive the information. In fact, using the gadgets, we are sending and receiving the information every day, like talking on a smartphone or sending an email to someone, and even watching the television or the examples of different communication systems. Now, let us discuss about the block diagram of communication system. Through the block diagram of communication system, let us understand how the information is shared between 2 points. In this block diagram, the first block is the source from where the message signal is generated. This message could be a voice, an email, or a television signal, or it could be even some data signal. If this message is a non-electrical form, then using the transducers, it is converted to electrical signal. The microphone, CCD camera, and the computer keyboard are the examples of the transducer. For example, using the microphone, we can convert the voice signal to an electrical signal. And using the camera, the picture or motion can be converted to digital signal. So after this transducer, the electrical signal which we have is known as the input signal or input message to the communication system. After this transducer, the next block is the transmitter. This transmitter modifies the input signal for the effective transmission, and this transmitter module also contains several subsystems like modulator, the analog to digital converter, encoder, and amplifier. For example, if the signal is analog in nature as shown here, right, and it need to be converted into digital form, then first it is sampled at a regular interval, and then it is quantized, and after the quantization, using the analog to digital converter, it is converted to digital form, and later it can be encoded in a particular format using the encoder. And usually for the effective transmission, the signal is modulated using the particular scheme. So this modulation is the process where the property of the periodic signal like the amplitude, phase or frequency is altered according to the input signal. And of course, in the upcoming videos, we will talk in detail about this modulation. So anyway, these are some of the subsystems of the transmitter module. Now we will talk about the transmitted signal. Then we need to know certain characteristics of this transmitter signal, like whether it is analog or digital signal. What is the frequency of the signal? If it contains multiple frequencies, then what is the range of the frequency in the transmitted signal? Or in other way, what is the bandwidth of the transmitted signal? And if the signal is transmitted in the digital form, then at which rate the data is transmitted, or in other words, what is the data rate or the bit rate of the transmitted signal. Then another important aspect is the power level of the signal, because that will decide how long the signal can be transmitted over a particular medium faithfully. So there are some of the aspects which are very important for the transmitted signal, and one need to see these aspects while designing the communication link. So the signal after this transmitter is known as the transmitted signal. This signal is sent over the particular channel. So a channel is a medium over which the signal is transmitted over the certain distance. This channel could be a physical channel like optical fiber or coaxial cable, or it could be a wireless channel like a radio link. This channel partially behaves like a filter and attenuates the different frequencies of the transmitted signal differently. Once the transmitted signal passes through the channel and gets received at the receiver, then it gets attenuated as well as it is being distorted. Moreover, the noise also gets superimposed over the transmitted signal. If this is the transmitted signal at the transmitter end, at the receiver we may receive the attenuated as well as the distorted signal. By what amount the signal will get attenuated and distorted will depend on the length of the channel. So if the signal travels longer in a particular medium, the attenuation and distortion of the signal will be more as shown here. But the detector or the receiver should be able to recover the message signal from this distorted signal. And whenever the detector is able to recover the signal or not, it depends on the signal to noise ratio. So it is a very important parameter in communication. This parameter is the ratio of signal power to the noise power. So by increasing the signal power, the signal to noise ratio can be improved and the signal can be transmitted over a long distance faithfully. Now, many times the signal need to be transmitted over a much long distance. It is not possible to increase the signal power beyond a certain limit. So, in such cases, regenerative repeaters are used after a certain distance. So, these regenerative repeaters detects the distorted and the noisy signal and generate the fresh copy of the transmitted signal, and then the signal is once again transmitted over the particular channel for a particular distance, after which again it is being given to a repeater that detects the distorted and the noisy signal. So by means of which we can send a transmitted signal for a very long distance without any distortion in the signal. For a transmitting medium or a channel perspective, following are the important specifications. The first is what is the length of the channel or a distance over which the signal can be transmitted faithfully. Then another important specification is the bandwidth of the channel. So it is the range of frequency which is supported by the channel with reasonable fidelity. For example, if a particular channel can transmit the signal in the range of 0 to 20 kilohertz, then we can say the bandwidth of channel is 20 kilohertz. And if the signal is transmitted in digital form, then for the digital signal, another important aspect is the data rate. That is the maximum supported data rate by the particular channel. So these are all some of the important aspects of the channel perspective. Now at the receiver, the received signal is be modulated, and if the signal is in digital form, then first of all it is decoded, and using the digital to analog converter it is converted to analog signal, and after the proper amplification this signal is given to the output transducer. So this output transducer could be a speaker, or it could be even a display screen of smartphone or the monitor. So this is the basic block diagram of communication system and a little overview of how the information or the message is transmitted from one point to another point. Let us discuss about the modulation, need for modulation, and the types of communication in the next video lecture. Thank you.